Welcome to Industrial PLC Applications. This video is an introduction to network communications. This is part 1, focusing on hardware. After completing this video, you should be able to identify basic Ethernet components and hardware, explain the functions of those components, and identify and explain a MAC ID. Networking is a very large subject. The purpose of this video series is to introduce the basic hardware, connection concepts, and interconnectivity principles of Ethernet networks and familiarize you with some simple networking terms. Later in the series, we will demonstrate how to establish an Ethernet connection to a Micro 850 and the network. First developed in 1973 and 74, Ethernet has had many updates and improvements, including data speed, bandwidth, reliability, and protocol flexibility. By adding Ethernet connectivity to the PLC, not only can the PLC communicate with a PC, it can share data with other PLCs, HMIs, VFDs, and expand its I/O complement and control range. PLCs can have many different communication methods to connect the PLC processor to a computer or maintenance logging equipment. Some of the various methods were pioneered by Allen Bradley, such as Data Highway Plus, DeviceNet, ControlNet, and now Ethernet over Industrial Protocol. This video will familiarize you with some of the hardware used in an Ethernet connection between the PLC and the PC. Earlier, in Industrial PLC Applications, we learned how to connect the Micro 850 to a laptop PC by using a USB AB cable and the USB port. We also mentioned there are two other connections a Micro 850 can use to communicate with other devices: an RS-232 serial port and an Ethernet port. The RS-232 serial port is considered to be a legacy port in that not many devices still use this old serial transport method, basically due to bandwidth and speed restrictions. However, it does provide an access for the Micro 850 to communicate with older PLCs, VFDs, and human-machine interfaces or HMIs. We will now focus on the Ethernet port, since Ethernet has become the de facto network communication platform around the world, and many industrial facilities have adopted Ethernet for their PLC-PC communications. Ethernet is a networking, wiring, and communication protocol that can transfer vast amounts of data quickly and reliably. So what exactly is Ethernet? Well, Ethernet is a family of wired computer network technologies commonly used in local area networks or LANs. The hardware port of a Micro 850 accepts an RJ45 connector. In all Ethernet wired connections, both ends of the cable have male RJ45 connections. Wireless transmissions are considered to be Wi-Fi. Ethernet is strictly cabling. However, they share something called a Common Access Point or AP. In order to create even a small Ethernet network, make sure you have the following. 1. Each device in the network has a suitable RJ45 Ethernet port and the internal hardware, similar to the Micro 850s that's shown. Make sure you have Cat5e or Cat6e Ethernet cabling with male RJ45 connectors on both ends. And then determine how they are to be connected together. Not all connections are created equal. There's a slight snag when it comes to connecting devices together. There are a few ways a cable can be constructed in order to facilitate inter-device communications. In essence, it's important that the data transmitted from the transmission port of one device is received at the receiving port of the other device and vice versa. There are two basic wiring configurations: straight-through cables and crossover cables. Straight-through cables, as can be seen in the diagram shown, are wired straight through, pin to pin, no crossing over. These are used to connect devices to routers or switches. Notice that pin 3 of one device is the receive transmission pin, and it is connected to pin 3 of the other device, which is the transmission pin. Crossover cables, as the name suggests, have wires crossed over to provide RX to TX interconnectivity. These are used for cables connecting two computers directly through their Ethernet ports, or a computer to a PLC. So a simple Ethernet network can be two devices directly connected together. But in order to have more than two devices, an intermediary device must be inserted. The cheapest device used to be the Ethernet hub, but these were replaced by Ethernet switches. An Ethernet switch is used because it can differentiate all of the devices on the network and can ensure that the data traffic will be sent to the correct destination. This is due to something hubs cannot do. It can examine the transmission data enough to determine the sender and the intended recipient. And this is because of the format of the data transmission itself. Without diving too deeply into it, Ethernet data transmission is broken down into packets. These packets are divided into sections or frames. Notice in the above image, both the destination address and the source address are contained in the packet ahead of the data itself. In this way, the switch can determine where the data is supposed to go without examining the data. Here's the question: what are these addresses? Every Ethernet device manufactured has a unique firmware embedded digital fingerprint called its Media Access Control ID, or MAC ID for short. And this is its permanent Ethernet address. These addresses are made up of 6 1-byte hexadecimal values separated by colons. The Allen Bradley shown, for example, is 5C:16:A3:A2A:85. These addresses are embedded within the data packet being sent and are read by the switch. These MAC IDs are found on any Ethernet media, including Ethernet fiber optic switches or radio wave devices like Wi-Fi. IP addresses can change, but MAC IDs don't. This is how a laptop running Windows can communicate with an iPhone or an Allen Bradley PLC on the other side of the planet and still have the data received by the intended device. Switches work fine for smaller, self-contained networks. But if an Ethernet device needs to communicate with a different network, say the World Wide Web, then a new device needs to be used called a router. A router typically has two sections: the local area network switch and the wide area network connection. The switch portion connects the wire devices on your network to each other and the router. That's the local area network half. The wide area network port connects your local area network to your ISP's network. That's the World Wide Web. To keep track of all the data traffic, routers create a router table. The router table has two sections: the LAN section, which controls the LAN devices, and every time a device connects to the router, it is assigned an internal IP address that is tied to that device's MAC ID. This includes Wi-Fi connected devices. The WAN section controls the connections to the World Wide Web or gateway servers. As far as the World Wide Web is concerned, the IP address of this single device is the one assigned to it by the Internet Service Provider. Okay, so to review. In order to set up an Ethernet network or interconnections, you require equipment having Ethernet hardware and RJ45 Ethernet ports, Cat5 or 6 cabling with 2 male RJ45 connectors, and use the correct wiring for the application, straight or crossover. If more than 2 devices need to be connected, then an Ethernet switch will be needed. If your device needs to communicate with another network, then an Ethernet router will be required. Data traffic is controlled by Ethernet packets of data containing the unique media access control ID address of both the sender and the recipient, and by the switch or router being able to look at the MAC ID embedded in the packets and direct the data to the correct recipient. In our next video, we will look at IP addresses. Until then, thanks for watching.